Good morning, students. Welcome to the college, Islamia College, and welcome to the Department of Physics. My name is Dr. Major J. Asgar. I am going to deal with Unit 3 of your syllabus. So you may be a little bit feeling difficult in understanding English. If you learn English, you will be very coming up topmost in your life. So you must know English. Communication English is very must and most important for your college education. So I welcome once again you all to the Department of Physics on behalf of the head of the Department of Physics, my own and my colleagues. Today we are going to see Unit 3 surface tension. Before going to that, I am going to give you a small introduction. All solids, liquids and gases are made up of a number of molecules. That is the first point you should remember. All solids, liquids and gases are made up of a number of molecules. And among these molecules there will be some force. That force depends on the nature of the molecules and the distance of separation. So you know already in 12th you have studied two types of forces. One is known as force of attraction, another one is known as force of repulsion. If the force is existing between two different types of molecules, it is called force of attraction. If it is existing between same molecules, it is known as force of repulsion. Likewise, in a surface tension, there are two types of forces. One force is known as adhesive force and another force is known as cohesive force. In surface tension, there are two types of forces. Number one, it is known as adhesive force and number two, it is known as cohesive force. If the force of attraction is taking place between two different molecules, suppose I am taking water in a glass beaker, force of attraction between glass and water molecule is known as adhesive force. If the force of attraction is taking place between same molecule, between water molecule or glass and glass molecule, then it is known as cohesive. So you must remember, adhesive force means force of attraction between different molecules. Cohesive force means force of attraction between same molecules. So that is the introduction. Now we are going to see what is meant by surface tension. Surface tension of a liquid is defined as the tangential force per unit length acting on either side of an imaginary line drawn on the surface of the liquid. Okay, you see my notes which I have sent already in the classes. I have sent notes in last two classes. Take my notes, keep it side by side, listen my lecture, and you can see that whatever I am saying in the lecture will be available in the notes. So once again I will repeat you what is the definition of surface tension. Surface tension of a liquid is defined as the tangential force per unit length acting on either side of an imaginary line drawn on the surface of the liquid at rest. Okay, in short, we can remember the surface tension as force per unit length. You can remember this as force per unit length, force by length. Otherwise, you can remember surface tension is equal to force by length. Unit of force is measured in terms of Newton, length is measured in terms of meter. Therefore, the unit of surface tension is Newton per meter. So, this is not a definition, this is only for your understanding. Before that, what I told you have to write in 2 marks, they will tell. Define surface tension means the definition which I give previously, you have to write that. So, definition of surface tension in short term is force per unit length. Therefore, force is expressed in newtons and length is expressed in meter. Therefore, the unit is Newton per meter. And the dimension can be written as mLT power minus 2 by L. This is the dimension for force and L is the dimension for length. Therefore, L and L will cancel. Therefore, the dimension is nothing but mt power minus 2. So, you know the dimension means expressing length, mass and time. Mass is expressed in terms of capital L, length is expressed in capital L, time is expressed in T. That is what dimensional formula. and unit is nothing but SI, International System of Units. So you are representing in terms of Newton. So you may have a doubt, sir, will they ask this in a question? They will not ask anything related to this. Just I am giving you the basic. They will only ask define surface tension. That's all. Sometimes they will ask define adhesive and cohesive force. Adhesive means the force existing or the force of attraction between different molecules. Adhesive, different, cohesive, you have to remember same. So this is a 2-mark question. Now we are going to see 5-mark question, that is molecular interpretation of surface tension. Molecular interpretation of surface tension. This is in your syllabus. Otherwise, sometimes they will ask or kinetic theory. Kinetic theory of surface tension. It has got 2 names. One is molecular interpretation of surface tension and second one is kinetic theory of surface tension. You need not worry about the words molecular interpretation or kinetic theory, because it is nothing but it is going to be explained how the molecules are behaving due to surface tension. What is the behavior of molecules in a liquid due to surface tension? One thing you have to remember, the process of surface tension is to make the area minimum where it is acting. The property of surface tension is to make the area minimum where it is acting, or surface tension will be acting like a stretched elastic membrane. The main important property of surface tension is to make the area minimum where it is acting, or it behaves like a stretched elastic membrane. Okay, one example I will tell you, nothing but before brushing your teeth, when you see the brush bristles, it will be open. When you brush with the help of a paste and dip inside water, you can see that the bristles of the brush will cling, C-L-I-N-G. Cling together means they will stick together. That is nothing but due to surface tension. That is what I am telling. Surface tension has the property to make the area minimum where it is acting. Now we are going to see molecular interpretation. So I am taking a glass tube. Inside a glass tube I am taking liquid. Inside a glass tube I am taking a liquid which is very crystal clear. I am taking a liquid which is very crystal clear. So this is the glass beaker. Now I am going to consider 3 molecules. One molecule is A. Another molecule is nothing but half of it, quarter of it will be in upside of the surface of the liquid, B. Another molecule I am going to consider, that is nothing but C. Now this is the center of the molecule. This is the center of the molecule. Here the force of attraction is acting in all directions. Here the force of attraction is in the lowermost section. Here the force of attraction is in the 3/4 section. Let us consider a glass beaker. It is filled with a liquid. Now we are going to study molecular studies. Let us consider 3 molecules, A, B and C. The molecule A is well inside the liquid. Therefore, the resultant or net force of attraction on the molecule A is 0. Now you will have a doubt. Why, sir? The upward force is equal to downward force. Therefore, the net resultant force acting on the molecule A is 0. That means surface tensional value is 0. Surface tension is nothing but a type of force. That you have to remember. Now let us consider the molecule B. When you consider the molecule B, 1/3 of it present on the surface and 3/4 is below the surface. Therefore, the force of attraction is very less. Therefore, the force in the upward direction is not equal to the force in the downward direction. Therefore, the net resultant force acting on the molecule B is in the downward direction. Now we are going to consider a molecule C. Half of it is 3/4 is half of it is present in the upper side, half is present in the lower side. Now you can say that the molecule C is in equilibrium state. Equilibrium means same level. Equilibrium is what? Same level. So first molecule is present well inside the liquid. The molecule B 1/3 is present on the surface. In the molecule C 1/2 is present. Therefore 50% upward direction force, 50% downward direction force. So you can say that the molecule C is in equilibrium. So when you are asking this question, they will ask in 5 marks. Write the molecular interpretation of surface tension or kinetic theory of surface tension. Means first point you have right. Let us take a glass beaker filled with the liquid. Let us consider second point, 3 molecules A, B, C. Third point, the molecule A is present well inside. Therefore, the resultant force acting on the molecule A is 0 because the upward force is equal to the downward force. So, no surface tensional effect is seen. Let us consider molecule B. 1/3 of the molecule is present inside the liquid. 1/4 of the molecule is present on the surface of the liquid. Therefore, the force of attraction is higher in the downward direction than the force of attraction in the lower direction. Therefore, the molecule is the force is acting in the downward direction. That means the surface tensional force is acting in the downward direction. So now I am going to consider molecule C. 1/2 of the molecule is present over the surface of the liquid, other half is present downward of the surface of the liquid. Therefore, the upward force is equal to the downward force. Upward attraction force is equal to downward attraction force. That means the molecule C is in equilibrium state, same state. Therefore, the surface tension is acting. There, the surface tension is due to cohesive force of attraction. I told you cohesive means force of attraction between same molecule. There, in the molecule C, force of attraction is taking place between the water and water molecules because there is one sphere known as sphere of influence. When the force is at the center, you say that it is known as sphere of influence. Force at the center and radius of the molecule, a force will be attracting, and that force is known as force of attraction, and that sphere or that molecule where the force is acting is known as sphere of influence. Therefore, the surface tension force will be acting. The main of the surface tension force is to keep its area minimum where it is acting. And from the molecular interpretation of surface tension, we are going to come to a conclusion that surface tension behaves like a stretched elastic membrane. Surface tension behaves like a Thus, the surface of the liquid is under tension and behaves like a stretched elastic membrane. So, if you write all these points, 8 points, your answer will be fulfilled for 5 marks. See you. Thank you.